Good afternoon. Just put a timer. Good. So good afternoon, everyone. Thank you all for not going home this late. Last talk of the conference. You all know that there is a recording, and yet you're here physically. So thank you for actually being here. I'm going to share a trick that is present in a GPT-4's paper, and unknowingly, I also found out about myself, and then found out that it's mentioned briefly in the paper. And show you some experiments and just show how powerful this trick really is. I'm going to spoil everything to all of you. The trick is reinforcement learning from in-human feedback. This is a trick for anyone that want to go home right now. Now you can. Anyway, let's start. One thing about the presentation, it might feel a little bit condensed. It was designed for a longer time, and we tried to squeeze it and cut parts of it. So don't take it easy. If you just lose it, there is a recording for everything. Slides going to be online. So that's it. Okay, so let's start from the beginning. How those things trained allegedly, because we don't know. Basically, there are 3 steps: pre-training, retraining, fine-tuning, and reinforcement learning. And if we talk numbers, I'm sure that you're all aware right now that pre-training is the part where 99% of the compute goes, also 99% of the cost, thousands of CPU, months, it takes millions of dollars, and you all know that. Fine-tuning gets you models that are, for example, Vicuña, that are, it takes are roughly tens of GPUs for days, and also is not cheap. And reinforcement learning is extremely experimental at this point, so I'm not going to go through exactly what it takes, but I just want to tell you all that apparently there is a fire sale nowadays, and you can all do this for at your home, pretty much, even to the extent that many of the huge models are free. You can do this on Google Colab. It is so easy, actually, that I even encourage those that are brave enough to actually go and try to do this right now. Pull out your phone. I'm going to give a couple of seconds for anyone brave enough to actually do this. And I want to say that training LLMs is easy. Getting high-quality data is a challenge, okay? So what I'm trying to do is give you this as a tool. So you can, this will be solved for you, the actual training, and you can go and plug in your own data and see the results, and think for yourself if you want to go this way. But I'm just trying to give you this as a tool so you can try and play with it yourself. Fine-tuning is extremely easy nowadays. You're going to see a lot of this during the presentation, a lot of examples of how easy it is actually to do. So getting back to the process, let's talk a little bit about fine-tuning. How those models are actually, about pre-training, sorry. Those models are actually pretty much trained on huge chunks of text, as you probably know. The trick is that the whole point here, the whole magic, comes from the data being extremely wide in terms of topics, and that's pretty much it. We also know quite a lot about this step. We know that most of the capabilities and knowledge of the language models actually come from this step and not from the later on steps in the process. If you are going to try and attempt to do something like this yourself, the most important thing is that deduplication makes language models better. This is literally the name of the paper. And we also have hints that it is even more extreme, that replications in the data pretty much destroyed language models from the inside unproportionally. So this is about that. Currently, this step is costly. It's not for the everyday guys to do at home, but you can attempt. You can do this. There are even Israelis that do this, that train Hebrew models, and they actually do this at home. And unfortunately, it is a little bit pay to win. The more money you put in the model, the better model that you get. There is no way around this at the moment. So let's talk about tokenization. People speak words. Language models speak numbers like every other neural net. So basically, if you're not aware of it, the way this works, basically you take a bunch of text and you assign every pair of letters or triplet of letters some integer number, and then you just get a long sequence of integers. We use simple statistics to find the exact mappings of those integers. I'm sure that you're all aware of it. It's more for this to be in the slides for anyone that wants this to be a summary of the topic. So then then the way the models are trained is basically you take everything, just concat the whole text together, delimited by a special token and of text, put them all in one table of batches. And then the way this works is that every token try to guess the next token based on everything that came before. Most of you probably recognize this. This is from State of GPT by Karpati. Great talk. Many of the concepts for explaining comes from this talk. I recognize that these are great explanations as well, just as all of you. So shout out to the talk. Absolutely amazing talk. Totally worth your time. Anyway, there is a problem for this that not many people are talking about. If you try to attempt to do this yourself, you will encounter it immediately, because every token try to predict the next token based on everything that came before. Some of the tokens predict it based on unrelated documents, because this is how we do it. So I just want to point out that the solution for this is extremely simple, and if you want an example for how to do this, you can find it right here on the most powerful open source models. You can look at the training codes and you will see small bits and pieces that make them this way. And many people just don't talk about those things in presentation because they are boring. It's not cool to talk about, yeah, there is a problem with the way we do this, but I really want to give you the full picture of as someone that went through all the possible mistakes along the way already. So just for you to know. Okay. So once you start training, the best course of action at this point is basically to get people from as many different religions as you can, and everyone prays that the laws go down, because every single minute you are burning thousands of dollars by the minute, every single minute when that thing takes place. There are many tricks that I can tell you that, can help you with stabilize the training and so on, but if you want one general rule is, if the model breaks out of the blue, simply go look at exactly the same time what text it saw. Usually you see with your own eyes, okay, I understand what happened. Usually you just see what happened. It is as simple as that. And if you want to read 100 pages book of horrors, good people of Meta AI released the logbook of horrors for actually doing all of this. You are more than welcome, and special thanks to the Meta guys, good guys of Meta, for not giving up, and on their second attempt, releasing one of the most influential language models of all time, open source, giving us all the little guys that sit at the table for the first time. So shout out to the guys from Meta. Okay, nice, but how do you actually, how do you really do this in real life? How do you actually do this? Okay. It looks intimidating, but in real life, the whole concept is really simple. Say that you have a text. I'm showing this as a text, but imagine these are tokens, and imagine it tokenized. If you slice it from the back, it goes forward. And if you slice it from the beginning, it goes back. Put the first one through your model and use the second one as your target. That's it. In real life, there are a little bit more lines that go in the code to do this, but the concept itself boils down to this, pretty much, okay? Speaking about real life, if you actually want to do this real life, I highly recommend not doing it yourself and simply use the simple command, this one, that will train the language model for you with a simple command from Hugging Face. If you want to learn more, go watch their tutorials, top notch, absolutely. So throughout the training, This is a GPT training on Shakespeare, again from Karpati's talk, just to show you how we progress through training. At the beginning, you get a model that is outputting some random text that is not even readable. And throughout the training, it starts to look like words, and moreover, down the line in the training, you get English, but it doesn't look like Shakespeare. But if you are not giving up and continuing the training, basically you get things that looks like your training data, obviously. So at the end of the day, you get a model that you can call your base model. And if you try to use it, it's probably not going to do what you want it to do at the moment, because those models are not trained to help you. They are trained to complete text. This is what they do. They don't want to help you. I don't need to go too much into prompt engineering in this conference, because I think you heard all about this nowadays. But just to give you a glimpse, there is an easy way to prompt base models to do what you want. Basically, you just give them some examples for how to solve a task. And if you want to even push it further, you can make it also look like a document, because the models want to complete documents. And then the model will be happy to complete the document by you tricking it to actually to solving your problem. Okay, that was about the first step. Next step, supervised fine-tuning. If the first step is it costs a lot of money, the second step is really accessible nowadays, and many people are doing it. We are just about to see. It is basically the same thing. Nothing changed. Just that if we, instead of just giving the model huge internet text, we just give the models examples for whatever we want it to do, like solving tasks or answering our prompts. As it turns out, it just works. Just works enough. It doesn't matter if someone tells you otherwise, because people had been saying things otherwise lately. But most importantly, it also works with synthetic data, which is much cheaper to produce at huge scale nowadays. And tens of thousands of people recognize this online. So things have been progressing pretty fast over the last couple of months. 2 weeks after the release of Llama, we understood that we can use synthetic data to create powerful models. Then 1 week later, we understood that we can measure ourselves using another model. It's really simple. You just give another model 2 outputs and ask it which one is better. It's a measurement. It's not the perfect measurement, but it's a measurement. 2 weeks later, we got to the point where we can ask a model to make samples harder and harder over time. And then a couple of weeks down the line, we got huge models unlocked for all of you. Some of you brave enough to actually run this on your phone. And literally 3 days ago, a new model that had passed 100% on the Vicuna table basically means that GPT-4 prefers it rather than ChatGPT 3.5. But this means nothing. I just want to say this whole who prefers what means pretty much nothing, but just look at the trend and the speed. This is what I want to say here. Again, on this leaderboard, it's a nice leaderboard. Okay, I like the trend, I like the idea, but I'm not sure how much probabilistic model that look at probabilistic outputs can be a measurement that you can trust. Okay, but the trend, like, is what I'm talking. Is what I'm saying. That please look at the trend. Okay, so last step, and this is what we all came here for. Let's talk about reinforcement learning. And on this, I'm quite alone at the moment, because people don't go there at the moment. Everyone's fine-tuning normally. So let me tell you I'll tell you a little bit about what I found out and a little bit about the basics of it. Today, the way this works is as follows. You have your model, it's fine-tuned, you prompt it and get a couple of completion options from the model. Then you just ask someone which one is the best option, and that person assign a rank to each of them. In real life, this is how it looks like. You get a batch of prompts. All the prompts are the same length. Obviously, it's the same prompt, but you get different completions that the model created, and you put a special token at the end, which is the reward of the model. And if you think about it, it's tricking the model, because then in real life, the model tries to get the text that at the end of it will be the best. Okay, so this, like, it prompts the model to actually create a text that at the end of it will be the best, and neutralizing completely the length of the text, which is important in this setting. Okay, and so you just assign the rewards to the end, and then to even make this whole process even more efficient, you just train a small model to guess what humans like what the person would have said, and use this model as your reward, pretty much. So, question, do we need all of this mess in the first place? You look at this and you can think to yourself, can't we just fine-tune? I mean, it's complex. Can't we just fine-tune? And the answer for that is I went to check. Here is a model fine-tuned with supervised fine-tuning. It's talking about, okay, it's funny. It's talking about a Chinese creator, because the only people at the moment they're actually doing this open source are on Chinese forums, which I collaborate with through Google Translate. I don't speak the language, but this is how it is. Anyway, this is with supervised fine-tuning, and this is the same model with reinforcement learning. And I'm sorry for the horrible editing here. This part of the presentation is like from 10 minutes ago. So yeah, it's a little bit rough, but it's really, if anyone wants to see this running to see for themselves, I can show you the output for you. Okay, it's not edited to say something. My question is why? Like, okay, why do we need all of this? Why can't we just use supervised fine-tuning for this step? 3 reasons why reinforcement learning works, and get models that are far different. If any of you, okay, all of you played with GPT-4 and 3.5, they are quite something different about them. And I think that this is what is different about them. So first, exploration. We don't want our models to answer word by word for what we say. We want them to say a thing that we want to say, but we don't really care about the words. If the model says the same thing with different words, it's fine. So RL allows the model to explore. Okay, so that's the first step. Second, RL gives the model a signal for what not to say. Supervised learning gives the model a signal for what is the right text to complete, but not what not to say. So this signal can only come from RL at the moment. Caveat, you can, if you really want, there are papers that are doing this, but put that aside. But most importantly, it allows the model to close the loop and get a feedback about its internal representation. Something like training models to say, I don't know, that is basically impossible with supervised fine-tuning, because if you just ask questions that are not in the training set and let the models know that the right answer is I don't know, what ends up happening is the model saying I don't know on random things. I tested it, I know. The model just learns to say I don't know. So if you want the model to condition based on its own knowledge, you have to close the loop. This is the magic that RL is incorporating into the training of the models. And moreover, you can ground it for code that work or crazy experiments of this sort. Okay, so this is what RL brings to the table. Getting back to this slide, what I would like to propose, put GPT-4 aside for a second, what I would like to propose, and I found this just playing around myself, instead of the human here, I would simply just ask another model as in the most stupid way possible, because humans are expensive, it's time, and you can ask models for free. So I just tried it to see what's going to happen, and as it turns out, it works much better than even training on Anthropic's data, which is kind of what everyone's testing on at the moment. My guess, it's just a guess, that we basically removed the reward model now. We just use the other model response. So we removed one of the models, so the error accumulates less. But it's just a guess. I don't know. I went out and called this zero-shot RL, and to later on found out that Anthropic already did it first and released a paper about this. But yeah, anyway, that's about it. So in short, just to summarize, in RL, model generates options, human selects the best one or ranks them. I just ask another model. And in real life, it is so simple that the way I do this is just ask a yes/no question, some model, and then as stupidly as possible, take the tokens of yes and the tokens of no, and just calculate the probability that the answer will be yes. This is the reward of the model. The probability that it will do what I asked this question to say. As simple as that. These are 4 lines, 0 human effort, and the training takes 10 minutes. Okay, it is as simple as that. I'll show you the full code in a second, so you can do it yourself. Again, slides are going to be online. What I want to emphasize here, and leave how powerful the models that turned out of this actually come to be, is that it is basically prompt engineering for training, which I didn't see anywhere else. Okay, so if everyone is prompt engineering nowadays to manipulate models to do something, you can manipulate them and train them at the same time with this approach. And it's so easy to do. I really encourage you to try it yourself. It's really simple. You're going to see the whole code. So just as I do what I do best, I just went to brag about it online to all of you. That's pretty much what I did with it. Here is the full code, and yeah, it's really cool. Some of you probably have seen this online. You can test it out yourself. It's really simple. You can take pictures if you want. You got the slides. It's going to be online anyway, but I'm just saying, it uses a TRLX. It's a really good package for reinforcement learning from human feedback. And it's really efficient. Also, it works really fast. So I encourage you, try it, play with it. It's fine. It works. Yeah, works with what you have. Okay. And then someone online pretty much poked me and said, wait, look here, right here. Okay. And this is not just a single sentence. There is a full paragraph talking about this concept in general in a different setting about safety and all of that. But I would like just to point out at the end of this talk that I don't know anything about GPT-4. Don't look at me. I have no special knowledge out of any other that you don't have. Okay. But I'm looking at the model that is absolutely powerful. It is different. Something about this is not the same as anything else. I don't know what, but something about this. Here is a really powerful model, a really powerful method that was hinted in a couple of words in its paper. So, and I might be wrong, so don't get my word for it. I have no knowledge. I just want to say it again. I have no knowledge. I don't know what's going on with GPT-4, but regardless, play with this because this is a really powerful method. And as I said before, there were more slides for this presentation. You can easily stretch this approach further. You can ask models, how could the other model improve its result? And then you get the result. did the model improve its results? Yes, no. And you can easily build huge pipelines. And I also connected it to Bing and Bard, and you get information from the internet mixed in, and you can easily stretch this. It's so easy to do. Okay, that's what I'm saying. It's easy to do, play with it. You have the code yourself. And just one last thing. Many people today have this question because of what is going on. Can we even compete? Like, is there even any, there is a reason for us to even try? Just want to say about that, because I think it's important. Even if the worst case scenario, the transformer itself would never be released and stay in the trade secret, even then open source models wouldn't be that far off, okay? So please don't give up on open source research. We might not have the money, but we have each other. And with all due respect, we are just as capable and far more many people. And with all due respect, transformers are once in a lifetime, okay? So, okay. Thank you very much. Thank you for staying so late. And more about this concept in the future, for sure.